We are studying signals and system, and today's topic is Laplace transform. Laplace transform is there in mathematics also, but signals and systems के पर्सपेक्टिव से Laplace transform एक बहुत ही इंपॉर्टेंट टूल है. सिमिलर टूल हमने स्टडी किया है Fourier transform. Fourier transform converts time domain signal to frequency domain signal. We know about it. But what Laplace transform do? It do the same thing. But along with that, बहुत सारी एनालिसिस में एंड सिस्टम एनालिसिस, सिस्टम स्टेबिलिटी में लैप्लास ट्रांसफॉर्म एक क्लियर पिक्चर प्रोवाइड करता है. ओके, फर्स्ट ऑफ ऑल विल अंडरस्टैंड द लैप्लास ट्रांसफॉर्म. ओके, एंड वीडियो विल बी टू लेंथी बिकॉज आई विल कंपेयर द फूरियर ट्रांसफॉर्म एंड लैप्लास ट्रांसफॉर्म इन द फर्स्ट पेज. सेकेंड में सो व्हाट इज द रीजन ऑफ कन्वर्जेंस. लैप्लास ट्रांसफॉर्म में इंपॉर्टेंट कॉन्सेप्ट ये है कि व्हाट इज द रीजन ऑफ कन्वर्जेंस, what is S-plane, and for same kind of Laplace transform हमें region of convergence different क्यों मिलता है, इसको भी हम समझेंगे. Okay, it's a quite interesting. Stay at the end of the video, you will understand the clear concept of Laplace transform by solving some examples. Okay, so first of all x of t is a time domain signal. Okay, एक one thing you have to remember that Laplace transform is applicable only for continuous time system. It's the best tool for the analysis to find the stability of the systems and time domain to S domain conversion. Okay, and x of t is a time domain signal and Laplace transform, okay, x of t, okay, L is operator. After this what we'll get? We'll get x of s. डायरेक्ट हमें ऑपरेटर है ना ऑपरेट करने के बाद टाइम डोमेन पे ओके विल गेट एक्स ऑफ एस आफ्टर यूजिंग दिस इंटीग्रल इंटीग्रेशन और माइनस इन्फिनिटी टू प्लस इन्फिनिटी एक्स ऑफ टी ई रेस टू माइनस एस टी डी टी. ओके, विल गेट समथिंग आफ्टर दिस सॉल्विंग दिस इक्वेशन दैट इज लैप्लास ट्रांसफॉर्म. यहां पर जो एस टर्म है वो एस टर्म, what is the s term we have here, where s is equal to sigma plus j omega. ओके, ये जो टर्म है ये टर्म एडिशनल है जो कि फूरियर ट्रांसफॉर्म में नहीं है. सो एंड रियल पार्ट ऑफ दिस, रियल पार्ट ऑफ s जो है whenever we'll call real part of s, it means we are talking about the sigma, value of sigma, and imaginary part of s, imaginary part of s जो है it is omega, जो j के साथ है that is imaginary part. Then where we have to use this? So it will take us to a new plane, a new domain. So what Laplace transform do? Very simple, हम लिखेंगे Laplace transform converts x of t to x of s, capital X, small s, x of s. It means, okay, metaphorically it is said that Laplace killed time, Laplace killed time. What is the meaning of this? Laplace kill time means where exactly it killed. Okay, we have time splitter just like AD, BC. Whenever we say this, it says it tells about the separation of time, before Christ, after Christ, like this. But here it is metaphorically said that Laplace killed time. Okay, Laplace completely converted x of t to x of s. So what is this? S domain. So S domain का जो एनालिसिस है it is doing using S plane. So S domain equation. Okay, and S domain equation जो है so वो equation को यूज करके हम जो S plane को यूटिलाइज करके हम we have some predictions, we have some analysis about this signal, and ये जो है ये है real part of S and this is imaginary part of S. Okay, and it's minus real part of S. and minus imaginary part of s. ओके, अभी रियल पार्ट ऑफ s क्या है? व्हाट एग्जैक्टली इट इज? रियल पार्ट ऑफ s है, हमने देखा रियल पार्ट ऑफ s जो है वो है वैल्यू ऑफ सिग्मा, दैट्स इट. एंड इमेजिनरी पार्ट ऑफ s जो है वो है वैल्यू ऑफ ओमेगा. सो इंस्टेड ऑफ रियल पार्ट ऑफ s you can write this as simply you can write sigma. Simply you can write minus sigma. Okay, and here it is j omega and here it is minus j omega. Write real part of s या फिर आप directly you can write this sigma. Okay, so real part of s indicate the value of sigma. Fine. अभी what is the difference between, हमारे पास Fourier transform है. Okay, compare Fourier transform and Laplace transform. जब इसका हम कंपैरिजन में स्टडी करेंगे हमें पता चलेगा कि जो सिग्नल का हम फूरियर ट्रांसफॉर्म फाइंड नहीं कर सकते उसका हम लैप्लास ट्रांसफॉर्म फाइंड कर सकते हैं. ओके, सो व्हाट इज द आंसर फॉर दिस? हमें इक्वेशन कंपेयर करने के बाद पता चलेगा कि लैप्लास ट्रांसफॉर्म का जो इक्वेशन है, व्हेन वी फूरियर ट्रांसफॉर्म का जो इक्वेशन है वो हमारा इक्वेशन है फूरियर ट्रांसफॉर्म इक्वेशन. ओके, so we have x of j omega is equal to integration or minus infinity to plus infinity x of t e raised to minus j omega t, okay, dt. हमें पता है कि x of j omega is a complex quantity and it is a continuous function of variable omega. ठीक है, जो हमें continuous ग्राफ आता है उसका. अभी देखिए some functions are not Fourier transformable, ठीक है, लेकिन they are Laplace transformable, that we have to understand. देखिए what is the Laplace transform equation? Say this, Laplace transform equation जो है वो है x of s, okay, is minus infinity integration of x of t e raised to minus est dt. Let us simplify this. इसको हम s की जगह क्या पुट करेंगे? पुट s इक्वल टू सिग्मा प्लस j ओमेगा. तो मैं what will get? x of s इक्वल टू माइनस इंफिनिटी टू प्लस इंफिनिटी x of t e raised to माइनस सिग्मा t इंटू e raised to माइनस j ओमेगा t dt है ना. s की जगह हमने पुट किया e raised to माइनस सिग्मा प्लस j ओमेगा t है ना. ये पुट किया तो क्या होगा? e raised to माइनस सिग्मा t e raised to माइनस j ओमेगा t. okay, so what is additional here? now see this, what we have, अगर ये टर्म को हम निकालेंगे बाहर, this term and this term, okay, this term, okay, so this term is Fourier transform. जो remaining part है, remaining part is Fourier transform. okay, if sigma equal to 0 it means e raised to 0 will be 1 and this equation will behave like a Fourier transform equation है ना. so we can write this as e raised to, okay, so Laplace transform, okay, Laplace transform equal to Fourier transform when sigma equal to 0. okay, when sigma equal to 0 we have the both integrals are same. ठीक है, first of all, okay, let us make clear about the Laplace transform. ठीक है, we'll solve one example of Laplace transform, then we'll go back to the Fourier transform. Fourier transform भी find करेंगे और compare करेंगे and first of all we'll understand the region of convergence. okay, so find x of t is equal to e raised to 2t u of t. okay, इसका हम Laplace फाइंड करेंगे, रीजन ऑफ कन्वर्जेंस फाइंड करेंगे, उसको अंडरस्टैंड करेंगे, देन विल गो टू Fourier ट्रांसफॉर्म. ओके, इसका Fourier ट्रांसफॉर्म पॉसिबल है क्या? नहीं है, तो क्यों नहीं है? ओके, सो Laplace transform of this Laplace transform of x of t is x of s is minus infinity to plus infinity x of t e raised to minus st dt. ये हमारा इक्वेशन है लाप्लास ट्रांसफॉर्म का. लेट अस सब्स्टिट्यूट दिस लाप्लास ट्रांसफॉर्म ऑफ e raised to 2t u of t is equal to x of s will get, and here comes the value of x of t. So this one is e raised to 2t u of t or e raised to minus st dt. What about u of t? ये जो u of t है हमारे पास u of t है ना, u of t, what is u of t? u of t we have है ना, u of t is 1 for t greater than 0 and 0 for t less than 0. It means we have such kind of waveform. ये देखिए, so 0 1 for u of t, and whenever we multiply anything using u of t हमें क्या मिलेगा? We'll get integration limit, we'll get from 0 to infinity. So ये effect है, whenever we multiply anything using u of t, so this is the effect of that. Integration का limit जो है this will go to 0 because of this. Okay, so हमारा जो next step में है, we'll simplify this. So what is this? X of s is equal to, this is changed limit 0 to infinity e raised to 2t. Now u of t disappeared and it is e raised to minus st dt. Okay, each and every step को हम explain करेंगे. Okay, even a layman will understand the solution. Fine. So it is 0 to infinity e raised to, okay, so it is minus s minus 2 t dt. Fine. So it is minus s and plus 2. Okay, if we simplify this, now we have to find integration of this, that is the Laplace transform. Okay, again I am copying this here. So x of s is equal to integration for 0 to infinity e raised to minus s minus 2 t dt. Okay, so what we'll get? We'll get e raised to minus s minus 2t divided by minus of s minus 2. ये हमारा इंटीग्रेशन है 0 टू इन्फिनिटी लिमिट है. ओके, हमने क्या यूज किया वहां पर? हमने एक फार्मूला यूज किया. वी हैव यूज दिस फार्मूला, इंटीग्रेशन ऑफ e raised to ax dx is equal to e raised to ax divided by a. Okay, and we have some limit, we have to substitute that limit. Fine. So next step is, it is equal to e raised to minus s minus 2. ओके, t के प्लेस पे हमें क्या पुट करना है? इन्फिनिटी का वैल्यू पुट करना है. सो इट विल बी इन्फिनिटी माइनस e raised to 0 डायरेक्टली s minus 2 into 0 divided by minus of s minus 2. So this is our answer, e raised to minus infinity minus e raised to 0 divided by minus of s minus 2, and our answer is, it is minus 1 divided by minus of s minus 2. Okay, so it is 1 by s minus 2. What is our x of s? So we got x of s equal to 1 over s minus 2. ये हमारा x of s है. Now let us talk about the Laplace transform s minus 2. Now here it starts, we have to find the region of convergence. And what is mean by region of convergence? Okay, so earlier we have not defined, so we have to define it. So what is the region of convergence is? So if you say, so these are, when we will talk about the poles and numerators, poles and zeros of the system, okay, we will talk about the how to locate the poles and zeros of transfer function. Okay, but here we have the Laplace transform of a signal. Okay, so it is s minus 2 equal to 0, therefore s equal to 2. So the real part of this, okay, what is the region of convergence? It is, region of convergence is real part of s should be greater than 2. Okay, we have to prove this. क्या होगा अगर हमने रीजन ऑफ कन्वर्जेंस लेस देन 2 अगर हमने डिसाइड किया, या फिर है ना, एंड इफ यू टेक रीजन ऑफ कन्वर्जेंस ग्रेटर देन 2, है ना, तो क्या होगा? ओके, वी हैव टू डिस्कस दिस एंड व्हाट इज द रीजन ऑफ कन्वर्जेंस. ओके, सो लेट अस टेक अगेन दिस हियर. यहां पर लेंगे हम x ऑफ s का वैल्यू जो है x of s is 1 upon s minus 2 and we have decided region of convergence real part of s is greater than 2. Okay, तो क्या होगा? And what is region of convergence? What is region of convergence? In short, it is called ROC. Okay, region of convergence. So it is the set of values of s for which Laplace integral what is Laplace integral? We have Laplace integral minus infinity to infinity integration of x of t e raised to minus st dt. Okay, so this what it converges, integral converges. Okay, so that region is called as ROC. So that region on S plane, okay, is referred as region of convergence. Okay, set of values of S. Okay, we'll check the set of values of S. Okay, next page, and we have x of s is equal to 1 upon s minus 2 and we have decided ROC रियल पार्ट ऑफ s जो है क्या होना चाहिए? ग्रेटर देन 2 होना चाहिए, या फिर सिग्मा का जो वैल्यू है ग्रेटर देन 2 होना चाहिए. ओके, सो लेट अस स्केच द रीजन ऑफ कन्वर्जेंस. ओके, सो रीजन ऑफ कन्वर्जेंस, first we'll show it and then we'll check this region of convergence and we'll try to understand completely the region of convergence. Okay, so it is the real part of, it is imaginary part of S, real part of S, imaginary, negative imaginary part of S and real part of S minus real part of S. सिग्मा का जो वैल्यू है एक तो प्लस होगा या माइनस होगा, इसीलिए वी हैव प्लस एंड माइनस रियल पार्ट. एंड व्हाट इज द रीजन ऑफ कन्वर्जेंस? Region of convergence is shown by a strip vertical to imaginary plane. Okay, कैसे show करना है? Using a strip. So we have to sketch a strip. Okay, and at what value we have to start? Okay, suppose it is 1 here and it is 2 here, 3, 4 and so on, minus 1, minus 2, minus 3. These are the values of sigma. Okay, you can write sigma plus sigma minus sigma. And what is region of convergence? Region of convergence is, so it is greater than 2. So here it comes the 2. Okay, and here we can show like this. We have to show the strip. So this strip, okay, so region of convergence is shown using a strip, this one. Okay, and where the strip goes, so it can go to, so this strip can go to infinity, all the values, and this side also it goes to this one, and this side this goes to this one, but this side it is not going anywhere, ये side में नहीं होगा. So this is what, this is region of convergence, ये जो है, so this is ROC. So it is ROC and real part of S should be greater than 2. Okay, and this is ROC. Let us check what happens अगर हमने ROC not greater than 2 ले लिया. Suppose 1, we have taken value of 1, what will happen? That we have to check. What is ROC? Try to understand it. Region of convergence, okay, the values of S for which Laplace integral converges. ठीक है? Let us check. इसको check करेंगे. Then we'll understand the concept of ROC. ठीक है? So x of S is equal to 1 upon S minus 2. Let us take S, okay, real part of S. हमारा जो value है वो है real part of S should be greater than 2. Okay? अगर हमने 2 लिया तो क्या होगा? Let us take S equal to 3, S equal to 4, S equal to 5. What we'll get? We'll get x of S equal to 1 upon 3 minus 2 is 1 upon 1, it is 1. And x of S for S equal to 4, so it is 4 minus 2, it is 1 upon 2. Okay? And S equal to 5, we'll get x of S is equal to 1 upon 5 minus 3. 5 minus 2 is 1 upon 3 will get. Okay? For this value it is getting. Now see the magic. For real part of S less than 2, उसके लिए भी हमें will get some answer, will get finite answer. But then why we are not taking? This is a big question. So here, twist starts here. Okay, this is for this region of convergence. For real part of S is greater than 2. Okay, let us take real part of S less than 2. Okay, it means for S equal to 1. Okay, let us check. So x of S का जो value है, x of S equal to 1 upon S minus 2. This is our Laplace transform. So what will happen? We'll get 1 minus 2 is equal to 1 upon minus 1. We'll get minus 1. Then why S equal to 1, real part of S equal to जो है sigma का value 1 है, तब ये region of convergence में क्यों नहीं है? Okay? तो ये यहाँ पर हमें आंसर मिल रहा है, लेकिन हमें ये चेक करना पड़ेगा कि लैपलास ट्रांसफॉर्म जो है वो कन्वर्ज करता है या नहीं करता है. ठीक है? सो दैट इज द एडिशनल फीचर ऑफ लैपलास ट्रांसफॉर्म. ओके, सो व्हाट वी हैव वैल्यू ऑफ s इक्वल टू 1. ओके, 1 लेंगे हम एंड विल सी x ऑफ s के साथ क्या होगा. x ऑफ s इक्वल टू minus infinity to plus infinity integration of x of t e raised to minus st dt. ओके, और हमारा जो इक्वेशन है वो है 0 to infinity after putting all these things e raised to minus, so it is s minus 2, so it is t dt. So here it comes the Laplace integration and the convergence. Okay, there are two things यहाँ पर, two interesting things है. Which one? One is convergence and other is divergence. Okay, we have to check whether this integral is converging or diverging. अगर converge हो रहा है then its Laplace transform is possible. If not converging, its Laplace transform is not possible. Okay, it converges with some conditions. Okay, so what will happen? Substitute s equal to 1 into this equation. यहाँ पर 1 substitute कर दो. क्या होगा? x of s is equal to integration 0 to infinity e raised to minus 1 minus 2 t dt. So this will become integration 0 to infinity e raised to 1 minus 2 minus 1 आएगा, so it is minus of minus 1 into t dt. So this is equal to 0 to infinity integration e raised to plus t dt. Now see this, here the main twist. So this equation जो है e raised to plus t, okay, what is the nature of this? This equation is growing continuously. Okay, it is growing and it is said that indefinitely integral, okay, Laplace integral is growing indefinitely for real part of s greater than less than 2. ओके, therefore ये जो है दिस इज नॉट इन द रीजन ऑफ कन्वर्जेंस. ये जो वैल्यू है लैप्लास ट्रांसफॉर्म का जो रीजन ऑफ कन्वर्जेंस शो किया है हमने, दिस इज नॉट पार्ट ऑफ द रीजन ऑफ कन्वर्जेंस. आई होप यू अंडरस्टूड द कॉन्सेप्ट ऑफ रीजन ऑफ कन्वर्जेंस. अभी नेक्स्ट हमें क्या करना है, नेक्स्ट पार्ट में हमें ये प्रूव करना है कि e रेस टू 2t u ऑफ t इसका फूरियर ट्रांसफॉर्म क्यों पॉसिबल नहीं है. ओके, एंड इसका लैप्लास ट्रांसफॉर्म पॉसिबल है with this condition. We are getting this region of convergence, but Laplace transform possible है, but e raised to 2t is a growing signal. इसका Fourier transform possible नहीं है. Okay, we can prove that also. Let us check Fourier transform of e raised to 2t. Okay, so x of t is equal to e raised to 2t u of t. ओके, इसका जस्ट हमने लैप्लास ट्रांसफॉर्म पॉइंट किया है और वी नो दैट कि इसका लैप्लास ट्रांसफॉर्म एग्जिस्ट करता है, बट व्हाई नॉट फूरियर ट्रांसफॉर्म. ओके, सो लेट अस चेक द सो फूरियर ट्रांसफॉर्म इक्वेशन वी हैव. So it is Fourier of x of t integral of x of t e raised to minus j omega t. Okay, ये इक्वेशन जो है दिस इज कॉल्ड कंटिन्यूअस टाइम फूरियर ट्रांसफॉर्म. रिमेंबर दिस. ओके, व्हाट विल हैपन, विल गेट फूरियर ट्रांसफॉर्म ऑफ दिस. क्या मिलेगा हमें, x of j omega. Okay, exact notation. We can call it as a x of omega also, but we have to remember that x of omega is a complex quantity. So what we'll get, we'll get minus infinity to plus infinity integral e raised to 2t u of t, ये हमारा x of t है, and e raised to minus j omega t dt. So this will simplify to, okay, so u of t है, इसीलिए this will become to 0. It will start from 0 and our integral is 0 to infinity e raised to 2t e raised to minus j omega t dt. The process is same. Okay, e raised to a dot e raised to b and e raised to a plus b. So this will be 0 to infinity e raised to, so it is 2 minus j omega t. Okay, t कॉमन लिया हमने and this one. What is the integration of this? है ना, इसका इंटीग्रेशन क्या है? So it is e raised to 2 minus j omega t divided by 2 minus j omega. ये हमारा इंटीग्रल है एंड लिमिट 0 to infinity. Okay, let us take ये जो t का वैल्यू है एंड इंस्टेड ऑफ infinity we'll take t, कैपिटल T लेंगे. Okay, we don't know the infinity and we call this as a t. Let us say t is t and t tends to infinity. We'll denote like this. So what is our integral? X of j omega is equal to, है ना, e raised to 2 minus j omega capital T and it is 2 minus j omega, है ना, ये हमारा इंटीग्रल है where t tends to infinity. What will happen? There are two cases. Okay, so it is omega equal to 0. Okay, या फिर ऐसा लेंगे हम 2 minus j omega, 2 minus j omega equal to 0. What will happen? So this term will be 0. Okay, and in this condition x of j omega is e raised to 2 minus j omega t divided by 0. So what we'll get? We'll get infinity. मतलब Fourier transform is infinity, means it is not Fourier transformable. for this condition. Okay, next condition क्या है? If t tends to infinity, in this condition, if t tends to infinity, what will be this one? Okay, this is not 0 and we'll get the infinity again. Okay, the Fourier transform of this growing signal, ये जो signal है, it is a growing signal and e raised to 2t, okay, u of t dt. Okay, this signal is indefinitely growing. Okay, why Fourier transform is not possible? क्यों possible नहीं है उसका रीजन ये है कि what is the condition for a function to be Fourier transformable. Okay, it should be absolutely integrable. So it is x of t dt should be less than infinity. Okay, and we are not getting less than infinity. Because of that, e raised to 2t u of t इसका Fourier transform possible नहीं है, जबकि इसका Laplace transform possible है. Okay, once again I will touch the concept. What e raised to है ना, जो एडिशनल टर्म है इसमें, जो एडिशनल टर्म है ना, e raised to, okay, what is additional term? X of t e raised to minus sigma t e raised to minus geometry, okay, dt. ये हमारा है Laplace ट्रांसफॉर्म. ये जो एडिशनल टर्म है, okay, सपोज अगर कोई फंक्शन है, सपोज दिस फंक्शन इज लाइक दिस, okay, ये फंक्शन है, okay, तो इसका जो Fourier ट्रांसफॉर्म पॉसिबल नहीं है, तब व्हाट वी हैव इंट्रोड्यूस्ड हियर, यहां पर हमने एक चीज इंट्रोड्यूस की है, एंड विच वन इज दिस वन, दिस टर्म, एंड दिस टर्म इज नथिंग बट दिस इज कॉल्ड e raised to minus sigma t. Okay, so e raised to minus sigma t is called damping term. Is called damping term. Okay, and it converges, okay, for sigma greater than 0 and sigma less than 0. Okay, sigma greater than 0 अगर होगा तो क्या होगा, this term will converge. When sigma greater than 0 e raised to minus sigma t will converge. वो कैसे होगा? Okay, let us take sigma equal to 1. So what will happen? So this will be e raised to minus 1t, and this is what? This is decaying. E raised to 1t is decaying signal, and sigma less than 0 अगर लेते हैं हम, तो e raised to less than 0 क्या होगा? minus 1 होगा. So minus 1 क्या होगा? plus होगा. If sigma equal to minus 1, okay, if sigma is less than 0 and sigma equal to minus 1, so what will happen? E raised to minus of minus 1t. So this will be e raised to plus t, and this is what? This is rising. Or growing. Okay, so for this condition sigma should be greater than 0. At that time ये function को converge करता है and it makes it Laplace transformable. This is the main difference between Laplace transform and Fourier transform. The video is quite lengthy, but after watching this, I hope you understood the concept of region of convergence and why this function is Laplace transformable while it is not Fourier transformable.